Welcome back, guys, to another video of mine. My name is Sinjan. I'm currently at IMA Bhubaneswar. This is my YouTube channel. There is also a blogging channel of mine. I will be sharing the link in the description box, and do follow it for more updates related to my channel and my personal and professional life. As promised earlier, I had said that based on the number of views and subscribers, I will be starting my own series for ISI and other entrance examinations preparation, where I will be teaching you various chapters which, according to me, are topmost on the priority list for the preparation of these exams. Today is the day when I start my first chapter, that is polynomials, for this preparation. Let me just be clear with you once more. ISI's entrance examination is on 11th May and CMI's entrance examination is on 24th May. So before 11th May, there is at least before a week, probably, that is 4th of May. Before 4th of May, today is, as far as I can see, it is 3rd of April and the exam is on 4th of May. So all over, I am getting approximately 1 month of time. In that, I will be trying to go through each video, I mean each topic, very minutely, starting from scratch and going up to the topmost level, provide you various question sets of whose solutions I won't be posting to all questions, but any doubtful questions I will be posting the solutions. Do mention the doubtful question in the comment section. I'll be starting polynomials today. My priority list would be polynomials, sequences and series, recursion and inequalities, number theory, permutation combinations and binomial theorem. Then I will be covering up geometry. And if possible, before geometry, I will try to cover up the calculus part. This is my priority list. I'll be very quickly sharing up previous questions, mock tests and all. Problem sets will also be shared today. That is, each day a video will come, probably each day or with a gap of 1 day. I will be trying to complete this one video where I will be taking up different topics under a single chapter within 1 hour 30 minutes to 2 hours max. Today I am starting with polynomials. So let me just give a brief overview for the polynomials, and I am really going to take this preparations very seriously, just as I had done in my student career when I was preparing for this examination. So I will be liking to teach you and guide you as a mentor and as a teacher and as your bigger elder brother. So do follow my lectures and do try to solve the question sheets. Polynomials. I have divided this chapter into 7 basic parts. I will be starting with polynomial functions. What are polynomial functions? Then comes the division of polynomials. Then I will be going to remainder and factor theorem. Then comes various important theorems, that is the integer root theorem, rational root theorem, all these. Then comes Vieta's relations and symmetric expressions, which is basically an extension of Vieta's relations. Then comes the common root case, and then comes irreducibility. One more thing to note down, guys. I, in my practice sheets, will be sharing up questions which I think will be up to ISI CMI level or a little bit higher, but I won't be going up for Olympiad questions. Max to max RMO, not above than that. No NMO, no international Olympiad questions, and no other countries' questions. Since I have seen and heard from my seniors that ISI and CMI don't ask you those levels of questions, if I think it necessary for a particular chapter, I will be sharing it with you guys and updating you up all. Do keep a check on my blog, whose link will be posted at the last in my description box, and do subscribe for more these types of videos. Okay, so let me just start. Sorry. Yeah. So my topic A is polynomial functions. We all know what are polynomials. Basically, any expression which is of the form an number n plus an minus 1 x to the power n minus 1 plus an minus 2 x to the power n minus 2 plus dot 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 a1 x plus a0. This is a function of x where my a0, a1, a2 all the way till an are real constants. It can be imaginary, but for now I'm considering it to be real. And my an is not equal to 0 and n is the highest power or the degree. What is this basically? An minus 1, an minus 2, they are all called as the coefficients. They are called as the coefficients. Is a function of x since all the terms are written in the form of variable x. My an is called the leading coefficient since it is at the front and it is the coefficient of the highest degree term of the polynomial. Okay, so I will be taking up a case. This, so nothing more to say of this, and any value of x, any value of x for which f of x is equals to 0 is called 0 of the polynomial. Zero or factor of the polynomial of the f of x. Okay, now a queer case, not queer. Let my fx be a polynomial of degree n and gx be a polynomial of degree m. So cases with according to this is fx plus minus gx will also be a polynomial hx whose degree or probably degree will be lesser than maximum of m comma n. Fx into gx will also be a polynomial p of x whose again degree will be m plus n since we'll be multiplying the highest order terms. Degree will be m plus n, and if I do a composition, that is f of g of x, that is putting my g of x in place of x in my f of x polynomial, this will again create a polynomial which is, let me say, k of x whose degree will be m into n. Remember this. Next. Polynomials can be added, subtracted, multiplied, divided within each other. That is, a polynomial can add, subtract, multiply, or divide with another polynomial or with a constant. Next, I will be coming up to my division of polynomials. Division, the other is very simple. Addition is basically just adding up the same degree terms. Subtraction again, subtracting the same degree terms. Multiplying is separately multiplying this polynomial with that polynomial, with each term getting multiplied to another term once. And my division is not complex, but yeah. Just to show an example, my x square minus 3x plus 2 is a polynomial which, if factorized, provides me these two factors, x minus 1 into x minus 2. I will just show that if I divide this polynomial by x minus 1, I will be getting x minus 2 and vice versa. How? Write x minus 1 here, x square minus 3x plus 2. Now x square divided by x, that gives me x. So I will multiplying x with this term. So x square minus 1 into x, that is x. Sign changes, this becomes plus, so x square gets cancelled. Minus 3x plus x, there is a minus 2x. My plus 2 remains. X minus 1 and minus 2x plus 2. So x into minus 2 is basically minus 2x. So x minus 2. My minus 2 gets multiplied to x minus 1. So that is your minus 2x plus 2. Sign gets changed. This gets cancelled. Remainder comes 0. So this is my quotient when dividing my x square minus 3x plus 2 by x minus 1. This is basically what division is. Next thing is my remainder and factor theorem. Remainder theorem. Okay. Let me have a polynomial f of x. Let me have a polynomial f of x. Now, let it have roots p and q. That is, f of p is equals to f of q equals to 0. Now I am taking a variable, not a variable, a value r, and I am trying to calculate my f of r will be how much. This will obviously be some constant. Now this is the remainder. Now what does it basically mean? Any value, if put in place of my variable in the equation, and which is not a root of the equation, we will get a particular fixed value which might be varying or might be same for different values taken up, but which won't be giving the value of a polynomial to be 0. That is the number which I am getting by putting any random number or probably a random character in place of x, or my variable in the polynomial, which is not a root. The value which I will be getting, that is my remainder. Like here, while dividing by 0 was my remainder. We all know the Euclid's division algorithm. We know it for normal numbers. Now I'll be showing, now it is just, we will change the values when trying to convert it for an equation. How? Let my fx be a polynomial, which is my dividend. So what we know, dividend is equals to divisor into quotient plus remainder. Let my divisor be another polynomial, which is g of x. I'll be getting some quotient will be q of x plus my remainder. We are good. Next comes up, let us say, in one of the previous videos I had told you about pattern remainder. Or probably before pattern remainder, I should just tell you for an remainder, equational remainder. In maximum of the cases, my remainder would be equation, not a constant number. I'm just looking out for some questions so that I can give you guys. Um, let's see if I can get some questions. Probably not. Okay. No problem. Equational remainder. Whenever I am gonna divide a polynomial by another polynomial, my remainder will be your, okay, so let me just frame it this way. If my dividend is of degree k and my remainder will always be of degree less than k, in maximum of the times it is basically k minus 1. We have to pattern remainder. What is my pattern remainder? I guess I have it some here in some of my problems. Yep, there we are. This is a good question. Proper usage of pattern remainder, it came in CM 1984. So my pattern remainder, what is it? I'm just gonna make you understand through this question itself. Zooming in. What do we have here? I am given a polynomial, that is f of x, whose degree is 4, and I do not know the coefficients, but I can see it is a monic polynomial. That is my highest, my leading coefficient is 1. This f of x basically has some roots within, 4 roots basically. but I am given that my f of 1 I am given, that is putting 1 in place of x, my particular constant value is given, my f of 2 is given, my f of 3 is given. So now what have I told about remainders? Remainders is basically you put anything other than the root in place of x, a particular value is given, that is my remainder. Here I am given that when I put x equals to 1, I am given a remainder of 10, x equals to 2 a remainder of 20, and x equals to 3 a remainder of 30. Is it possible to find a relation between my f of some other number and the remainder which I am getting? For example, f of 1 is equals to 10, f of 2 is equals to 20. So it is basically 10x. I can say my f of x to be 10x. That is, my remainder will be 10x. I can say it could probably have been, like this. Yeah. Here, what I have is my various coefficients are unknown. So I basically directly cannot find out my equations. One way is to put 1, then find out an equation between a, b, c and d. That is like this. If I put 1 plus of x, I get my 1 plus a plus b plus c plus d, which is equal to 10. My next equation would be 16 plus 8a plus 4b plus 2c plus d, which would be equal to 20. My next equation would be 81 plus 27a plus 9b plus 3c plus d, which would be equal to 30. So basically 4 unknowns, 3 equations, we will be solving it. But that is a huge lot of time taken, and entrances don't give you that much time. Entrance is basically not a selection test, it's like a strainer, just separating out a particular group of students from the rest. So you need to come in that particular group of students. For that you need to do things smartly. That is, for this question, I'll be expressing my polynomial in some other short. How? I have been given my 3 different values of x, that is x equals to 1, x equals to 2, and x equals to 3. And I'm also given a remainder. What I will be doing is, I will be expressing the polynomial in terms of those 3 numbers given. X minus 1 into x minus 2 into x minus 3 plus k square. I will be coming back to the question. Okay. Yeah. I have taken my fourth root to be t. This equation has 4 roots and this is a quartic polynomial. I have taken my fourth root to be t. I know my 3 roots, or probably I don't know my 3 roots, but I'm taking my 3 roots to be 1, 2, and 3. X minus 1 into x minus 2 into x minus 3 into x minus t. This full thing, like this x minus 1 into x minus 2 into x minus 3 into x minus t, this gives me a quartic polynomial plus 10x. Now why this plus 10x? This is basically my remainder. Like how? As I have said, if I put 1 in my equation, I am getting my value to be t. I am getting my value to be 10. Here if I put 1 in place of x, my LHS becomes f of 1, my RHS becomes basically x minus 1, so that is your 1 minus 1 is 0, 0 multiplied by anything gives you 0, and this time this side I am getting 10 into 1, that is 10. Similarly, if I put 2, my f of 2 is equals to 0 plus 20, f of 3 is equals to 0 plus 30. So what I can see, even if I have assumed my roots to be 1, 2 and 3 and t, I don't need to find my original roots. Using my remainder theorem, I can very well construct my polynomial and get me the required answer. Here, in maximum of these types of questions, I'll be given to find out some different values of f of some different x. Here as I am given f of 12 plus f of minus 8 by 10. This is what I am given up here. This full thing. So this is what I'm given up here. F 12 plus f of minus 8 by 10. My actual polynomial is this. X minus 1 x minus 2 x minus 3 x minus t plus 10x. Though my actual one is this, I have expressed this in terms of this. I'll be using the remainder theorem and trick. What do I need? F of 12 and f of minus 8. F of 12. That means I will be putting my 12 in place of x. So 12 minus 1 into 12 minus 2 into 12 minus 3 into 12 minus t plus 10 into 12. This gives me this particular thing. Similarly, in place of minus a, in place of x, if I put minus 8, I am given this particular things. This is what I come down to. I need to add both of these. Ironically, what I can see is my T and T is getting cancelled. So basically, we don't even need the unknown at last. Though at times of holding, we need to hold it. And we don't need to know the values of A, B, C and D. Very easily with the help of remainder theorem, we have taken out the values. I hope I am clear with this. Just writing it down here once. Example shown in previous video. My pattern remainder one. I wish I could get some one question for pattern remainder. Just a second, guys. Get it? You see one of my book. You can get something on that. Unfortunately, right now I'm not getting, but I will be obviously providing it in the question set which will be coming up today itself. I'll be pinning it in the description box. This is all about remainder theorem. Now comes my factor theorem. This column looks good. Next up is factor theorem. This is very similar to root. Basically, it is the root itself. X minus a is a factor of f of x if and only if f of a equals 0. In that example which I had shown, my x square minus 3x plus 2, if x minus 1 and x minus 1 are only factors, because if I put 1 and 2 at different times in two different cases in x, they will give me to 0. How? For example, x square minus 3x plus 2, if I put in a 1 in place of x, I will be getting my x square, that is 1 minus 3x, 1 minus 3, that is a minus 2 plus 2 is my left, so that is equal to 0. Nothing more to say in my factor theorem, I guess. It important in division. Well, I could get some questions. Just a second. I need a question for this to make you guys understand this a bit more. I have something in my mind. Okay, this is an interesting question. A little tough though. Just solve it up. This involves a little bit of number theory too. I will just try to make you understand. It is given if fx is a polynomial with integral coefficients, that is all my coefficients a0, a1 up till all the way till an are integers with integral coefficients and suppose f of 1 and f of 2 both are odd. That is, if I put 1 plus of x, the value which I would be getting for f of 1, that is my an odd number. F of 2 both are odd. We need to prove that. This is my condition given. Prove that there exists no integer n. There exists no n belonging to z such that f of n equals 0. In this types of questions, one method which is very evident is my contradiction method. That is the thing which I have been told to prove. That is f of n equal to 0. I will be holding it to be true and just try to prove it backwards that it's a contradiction. How do we do this? Very time to change colors up again. Let me solve it with yellow. Let us assume the thing to be proved is false. That means basically f of n equals 0 for some n is an element of integer. Yeah. Since at x equals to n my value is 0, so I can say my x minus n is a factor of f of x. Yeah. So by division algorithm, I can write my f of x to be x minus n into g of x, where g of x is again a polynomial with integral coefficients. Poly with integral coefficients. Yeah, you can very easily write it. Now, green is making a bit of a problem. I'm given my f of 1 is odd and my f of 2 is also odd. So now my f of 1 can be written as your 1 minus n into g of 1, and again my f of 2 can be written as your 2 minus n into g of 2 by following the division algorithm. Now they both are odd. They both are odd. But one thing which is noticeable is my 1 minus n and 2 minus n, they both are consecutive numbers. Yes. And for consecutive numbers, we know either of them has to be an even number. Has to be even number. Since we don't have two consecutive odds or two consecutive evens. Thus, this is contradicting the question. This is contradicting my question. Since in question given my f of 1 and f of 2 both should be odd. But contradiction. Therefore, this is how we will be writing in the UGB paper and my CMI second subjective paper. Full steps since we get step marking 2. Our assumption is wrong. Hence, the result holds valid. I hope this is clear. Very simple question. Just we assume something and we try to prove it wrong. Let me see if I can get some more questions. By the way, guys, this is a very good book prepared by the faculty at ISI. It holds previous year questions and huge lot of practice questions for BStat entrance examinations. Both subjective and objective papers are given. This is my test of mathematics and 10+2 level probably, and very commonly known as tomato. Guys who are And this is not only important for ISI and CMI. This is also very important for JEE mains and advanced too. Since you get a whole lot of multiple choice questions, huge practice with 100 to 110 questions per chapter, do serious preparation towards do by it. This is a very good book. I'll try to provide the link in the description box. Just see if I can get some good questions. Questions go. By the way, one small thing. We'll also cover logarithms, okay? Many a times in MCQs, ISI's UGA paper, logarithms are asked. Important thing, easy one. So yeah, I will be covering logarithms too. Yeah, I have got two different questions for you guys. One is based on my roots concept, and another one is based on my remainder concept. So we can do questions. First, let me do a remainder theorem question. It is given we have a polynomial f of x, which is your x plus x cube plus x to the power 9 plus x to the power 27 plus x to the power 81 plus, it is given in the MCQ parts, okay? Number 81 plus x to the power 243. This is my polynomial, and I'm saying it is getting divided by another polynomial g of x, which is basically x square minus 1. We're going to find out the remainder. That's cool. One thing, as I had said, while trying to figure out remainder, look at g of x, look at my divisor. Appropriately to the degree. Here my g of x is quadratic. That means the remainder which I will be taking to be h of x, that should be linear. One less than my divisor. Solve it. It's an easy question, a very nominal one. I'll just show it to you guys once. Yeah, done questions like this probably 9 or 10. By Euclid's division lemma, by Mr. Euclid's division lemma, by Euclid's lemma, division 1, okay? I can write my f of x to be g of x I'm not doing it. Yeah, g of x is my quotient. No, sorry, very sorry. Let it be h of x. Probably p of x looks cool. P of x is my remainder into g of x plus h of x. Write it. I have my f of x is equals to my p of x, which is my quotient, into x square minus 1 plus I have taken my h of x to be the remainder. What is my general linear polynomial? General linear poly. What is it? Ax plus b, where a comma b not equal to 0. Yeah. So let it be my h of x. Basically, we need to find out h of x. That is, we need to find out my a and b. This is how the question comes down by breaking up. I need to find my a of b, a and b. Then I will be getting to find my h of x. That is my remainder. That is what we are asked. So my f of x is x plus x cube up to the over 243. X plus x cube plus x to the power 9 plus x to the power 27 plus x to the power 81 plus x to the power 243. That is equal to my quotient, that is p of x, into x square minus 1 probably. Yeah. Which can be written down as x minus 1 into x plus 1 plus h of x, or probably I will be just writing this as x plus b. Ax plus b. Good. I'll be putting my two values. At first, let me put as at x equals to 1. The set becomes basically my 1 plus 1 2 plus 1 3 plus 1 4 plus 1 5 plus 1 6. This becomes my 6. 6 is equals to, at here 1, this whole term becomes 0. And at here, if I put x equals to 1, so this becomes my a plus b. This is my equation 1. At x is equals to minus 1. What do I have here? Minus 1, minus 1, minus 1, minus 1, minus 1, and minus 1. Since all are odd powers, so my minus 6 is equals to, what is this? Minus a plus b. Minus a plus b. Time to solve a and b, two equations, two unknowns. I will be adding them simply. So my LHS becomes 0. Here my a gets cancelled. I am left with b. So my b is equal to 0. So my a is 6. Hence, remainder, that is my h of x is equals to 6x. This is how you do a typical remainder theorem problem. Just look at the divisor, take my remainder, take the remainder to be a single degree less than the divisor, just put the values and calculate the unknowns and just solve it. Good question. Just a second, please. Okay, so let's move on to the next question. This is a nice one. Really nice question. What am I given? Px, sorry. My p of x is given to be a quadratic polynomial that is highest degree is 2. Quadratic polynomial whose values at x equals to 1, at x equals to 1 and x equals to 2 are equal in magnitude. Value equal in magnitude but opposite in sign. Okay, interesting. Opposite in sign but equal in magnitude. By the way, the solutions of this book, they are not given. Okay, I haven't searched it up on Google yet, but it's not given in the book. Both are given objective. The answers for objectives are given, but none of the subjectives are given. So for detailed solutions, you need to you, you can definitely ask me in the comment section. I am always there to help you. But opposite in sign. I'm also given -1 is a root. Then we need to find the other root is interesting. Okay. This is really interesting. Let's try to solve it. An easy one, not too tough, I guess. Yeah. So my px is a quadratic polynomial. So let it be your simply ax square plus bx plus c, where a not equal to 0. At x equals to 1, that is my p of 1 is your a plus b plus c, and my p of 2 is 4a plus 2b plus c. Value is equal in magnitude but opposite in sign. So basically p of 1 is equals to minus p of 2. That means p of 1 plus p of 2 is 0. If I take it in this form, then I'll be adding this 2. So basically 5a plus 3b plus 2c is 0. But again, complex to solve by taking a, b and c. That is why we are given my minus 1 is also a root. That is, p of x can be written as x plus 1, minus 1 is a root, so x plus 1 is a factor into x plus k. Yeah. So this is my p of x. Here things become very, very simple. As I can see, p of 1 is basically 2 into 2 plus k. And p of 2 is your 3 into 2 plus k. I'm extremely sorry. This is my one plus one, so this is my 1 plus k. Just a second, I think I'm getting one call. Normal calls. So my p of 1 is basically your 1 plus 1 2 into 1 plus k, and my p of 2 is your 1 2 plus 1 3 into 2 plus k. What am I given? My p of 1 is negative of p of 2. That means 2 into 1 plus k is negative of 3 into 2 plus k. Crux to find out k. I hope the process is very, very simple. So this is my 2 plus 2k. Two plus 2k is equals to minus 6 minus 3k. I can bring my k at this side. Can I? But probably, yeah. So 5k is your minus 8. K is minus 8 by 5. Just check it once. So minus 1 is a root. Yeah. So this is my answer. That's all for today, I guess. I have done it till my remainder and factor theorem. So this part is done. We started with the polynomial function. What are polynomials? Then I showed you some properties that if fx is a polynomial of degree n, polynomial of degree m, fx plus 1 is g of x, it gives me h of x, whose degree will be lesser than equal to maximum of either of the m or n. F of x into g of x, degree would be m plus n, and f of g of x, that is the composition of the function that whose degree would be m into n. Division, polynomials can be very easily added, subtracted, multiplied, and divided. I showed you one division, how division is done. Came back to remainder theorem, putting it in Euclid's division algorithm. Here so look at the degree of g of x and then take your k. Maybe then coming to factor theorem, if x minus is a factor of x, then my f of a has to be 0 if f is a polynomial with integral coefficients. Suppose f1 and f2 both are odd, and I showed you a question which involved a bit of number theory while looking up at the parity of odd and even. Then one remainder theorem question, then again one factor theorem question. So that's all for today, I guess. I hope you all liked my way of teaching. Any improvements, do comment it down. I am always ready to improve. And for my personal guidance, I am always there. Any problem, you can WhatsApp me in my number, that is 9434529524. This is my WhatsApp number. My Insta ID is Math. You can ping me up there. You can also get me in LinkedIn at Sinjan Sanigrahi. And my blog, yes, whose link I'll be pasting it in the description box. That is here. All small, okay. Sunny loves math dot blogspot.com. So yeah, this is my personal info. Contact me anywhere and at any time you want. I'm available 24/7 for any guidance, any tips, any help. I am always there. Any complaints, I am always there for that too. So yeah, that's all for today. My lecture 1, lecture 2 comes up most probably day after tomorrow. Stay tuned to my channel and to my blog. I'll be uploading the question set in the description box. So yeah, do like, share and subscribe, guys. Goodbye for today.